Hey everyone! Have you ever stared up at the night sky and wondered what it would truly be like to traverse the cosmos at unimaginable speeds? Imagine a world where you could travel at an astonishing 99.9% the speed of light. What would that truly feel like? How would your body, your mind, and even your perception of reality fundamentally change? Existence. Get ready to challenge everything you thought you knew about space travel. First, let's truly set the stage for this extraordinary thought experiment. The speed of light, often denoted as c, is approximately 299,792,458 meters per second, or roughly 300,000 kilometers per second. This isn't just a fast speed, it's the ultimate cosmic speed limit, a fundamental constant of our universe. Nothing with mass can reach or exceed this velocity. Traveling at a speed so incredibly close to this limit, specifically 99.9% of c, is not something we experience in our daily lives, nor is it achievable with current technology. Typically, our fastest human-made vehicles, like the Voyager probes, barely scratch the surface of 1% of this speed, moving at a mere fraction of light speed. Even the fastest spacecraft ever built, NASA's Parker Solar Probe, only reaches about 0.00067% of the speed of light relative to the Sun. So, when we talk about 99.9% of c, we are venturing into the realm of theoretical physics and science fiction, pushing the boundaries of what we can imagine. But if we could somehow achieve this astonishing velocity, the laws of physics, as laid out by Albert Einstein, would drastically influence every single aspect of our existence, transforming our reality in ways that are almost impossible to comprehend. At 99.9% the speed of light, the most profound and perhaps most famous effect you would experience is time dilation. This isn't just a theoretical concept, it's a proven phenomenon predicted by Albert Einstein's special theory of relativity. According to this theory, time is not absolute but relative, and it would literally slow down for you compared to those who remain stationary, say, on Earth. The faster you move, the slower your personal clock ticks relative to an observer who is not moving at the same speed. Let's put this into perspective. Imagine embarking on a journey to a star system just a few light years away. For you, the traveler, this journey might feel like only a few months, perhaps a year or two. However, for your friends, family, and indeed all of humanity back on Earth, years, decades, or even centuries could pass. You would return to a future that is vastly different from the one you left, a future where everyone you knew might be long gone. This is the essence of the famous twin paradox, where one twin travels at near light speed and returns to find their Earth-bound twin significantly older. The psychological implications of this experience are immense and deeply unsettling. Would you feel an overwhelming sense of isolation, a profound disconnect from your original timeline, as time marches on without you? The very concept of home and belonging would be irrevocably altered. Or would the sheer thrill of exploring the cosmos, the unparalleled adventure of witnessing new worlds, outweigh these profound concerns about lost time and forgotten connections? This temporal displacement would challenge your very sense of identity and place in the universe, forcing you to confront the transient nature of existence in a way few ever could. On top of the mind-bending effects of time dilation, there are other immediate and incredibly dangerous physical changes that would arise, primarily due to the immense acceleration required to reach such speeds. To go from a standstill to 99.9%, the speed of light in any reasonable time frame would exert tremendous, almost incomprehensible forces on your body. The human body is accustomed to certain levels of gravitational force, typically 1g, which is the force of Earth's gravity. Even highly trained astronauts can only withstand a few Gs for short periods without serious consequences. At 99.9%, the speed of light, the acceleration needed to achieve this velocity would generate g-forces far beyond what any human body could comfortably or even survivably withstand. We're talking about forces that would instantly crush bones, rupture organs, and turn your internal structure into a chaotic mess. Without some form of advanced inertial dampening technology, a staple of science fiction but currently beyond our scientific grasp, your body would simply be obliterated. Organ damage, loss of consciousness, severe internal hemorrhaging, or even the mechanical failure of bodily functions would become an immediate and unavoidable danger. Even if we hypothetically overcame the initial acceleration, maintaining such a speed would require constant energy input and protection from interstellar particles. A single dust grain, normally harmless, would impact your spacecraft with the energy of a nuclear weapon at these velocities. The engineering challenges alone are staggering, let alone the biological ones. This highlights the immense gap between our current technological capabilities and the theoretical possibilities of near-light speed travel, underscoring the fragility of organic life in the face of such extreme physical conditions. Furthermore, let's consider the truly spectacular, yet potentially overwhelming effects on your visual perception. At these incredible speeds, the universe would transform into something utterly alien, a cosmic blur that would challenge your brain's ability to process information. The familiar starry night sky would vanish, replaced by a distorted, vibrant, and perhaps terrifying spectacle. This isn't just about things moving fast. It's about the fundamental properties of light changing due to relativistic effects. One primary effect is the relativistic Doppler shift. As you approach celestial bodies, the light waves from them would be compressed, shifting towards the blue end of the spectrum. This phenomenon, known as blue shift, would make stars and galaxies ahead of you appear intensely blue or even ultraviolet. Conversely, light from objects behind you would be stretched, shifting towards the red end of the spectrum, redshift, eventually disappearing from view as their wavelengths become too long for human eyes to detect. The entire sky would appear as a tunnel of brilliant blue light ahead, fading to black behind you. Beyond color shifts, there's the phenomenon of aberration of light. Stars and galaxies would no longer appear in their true positions. Instead, they would seem to converge towards a central point directly ahead of your direction of travel, like raindrops hitting a fast-moving car's windshield. Objects in the distance could warp, stretch, and distort in bizarre ways, giving you an entirely new, albeit disorienting, view of the cosmos. This sensory overload, combined with the extreme speed, could potentially overwhelm your senses, making it difficult to discern anything meaningful from the chaotic visual input. Your brain would struggle to interpret this alien landscape, potentially leading to disorientation, nausea, or even a complete inability to navigate. As fascinating as this perspective shift is, let's not forget the profound effects on your internal biological systems. The immense energy required not just to propel a spacecraft, but to sustain a living body traveling even remotely close to light speed could lead to unprecedented metabolic changes as your body desperately tries to adapt to these new, extreme conditions. Our bodies are finely tuned to Earth's environment, and such a radical departure would push every biological system to its absolute limit. Consider the constant bombardment of high-energy particles and cosmic radiation. At near-light speeds, even the sparse interstellar medium becomes a dangerous environment. Without incredibly robust shielding, your body would be exposed to lethal doses of radiation, leading to cellular damage, DNA mutations, and a rapid onset of radiation sickness. Even with shielding, the sheer energy involved might induce subtle, long-term changes. Would your cells begin to operate differently, perhaps accelerating their repair mechanisms or altering their energy production pathways to cope with the extreme environment? What would that mean for aging, healing, or even the fundamental processes of life? Could your body's internal clock, so intricately linked to Earth's day-night cycles and gravitational pull, become completely disoriented? Would your sleep patterns, hormone regulation, and even your immune system function normally under such conditions? It's possible that your body would undergo a form of accelerated evolution, or perhaps simply break down. The very definition of biological stability might be challenged, forcing us to consider whether organic life, as we know it, can truly endure such extreme relativistic travel without fundamental genetic or physiological modifications. This journey isn't just about speed. It's about the ultimate test of biological resilience. Just for a moment, think about this extraordinary journey not just physically, but psychologically. Experiencing such wonders and challenges could redefine what it means to be human. The isolation of being separated by vast stretches of space and time from everyone you know would be immense. The constant awareness of time dilation, knowing that every second for you means years for others, could lead to profound existential crises. Would you retain a sense of self, a coherent identity, as the universe flies by in a flash, and your past becomes an increasingly distant, almost mythical memory? The psychological toll of such a journey would be immense. You would be a living relic, a time traveler returning to a future that is not your own. How would you cope with the loss of your original world, the absence of familiar faces, and the inevitable changes in culture and society? Could this journey redefine your relationships, your perceptions of time and space, and your very place in the grand cosmic narrative? The mental fortitude required to endure such an experience would be extraordinary, demanding a level of resilience and adaptability that few possess. Would our fundamental human needs for food, water, and social connection change? Perhaps the sheer awe of the cosmos would provide a new form of sustenance, or perhaps the isolation would drive us to madness. Could we find new ways to communicate or interact with the universe, fundamentally altering our place within it? This journey would not just be a physical one. It would be a profound spiritual and psychological odyssey, pushing the boundaries of human consciousness and challenging our deepest assumptions about reality. Before we dive deeper into these exhilarating possibilities and the future of humanity, don't forget to subscribe to our channel and hit that notification bell. We're constantly exploring the most mind-bending concepts in science and technology, and you won't want to miss our next deep dive. Stay updated on all our mind-bending explorations as we challenge the boundaries of science and reality, bringing you the most fascinating what-if scenarios. Now let's return to our journey at 99.9% the speed of light. Aside from the physical and visual transformations, there's an immense technological component to consider. Achieving such speeds would require propulsion systems far beyond anything currently conceived. We're talking about theoretical concepts like warp drives, Alcubierre drives, or antimatter propulsion, each presenting its own set of monumental engineering and energy challenges. The energy required to accelerate even a small mass to near light speed is astronomical, equivalent to the energy output of entire stars. Furthermore, the navigation and communication systems would need to be incredibly advanced. How do you plot a course when the universe is visually distorted and time is relative? How do you communicate with Earth when signals would take years to arrive, and your own time frame is so different? These challenges would spark innovative possibilities in technology and exploration, pushing humanity to invent entirely new fields of science and engineering. It opens doors to realms we've only dreamed of, pushing humanity toward new frontiers of understanding and capability. As we explore these ideas, it's evident that traveling at such cosmic speeds is about more than just the thrill of adventure or the pursuit of scientific knowledge. It's about understanding the ultimate limitations and capabilities of our minds and bodies and the universe itself. Each second spent traveling at high speeds presents new challenges and wonders, reshaping what we understand about ourselves and the cosmos. It forces us to confront our place in the universe, not as static observers, but as potential participants in its grand dynamic processes. The implications for interstellar travel and the exploration of other galaxies are profound. If we could master near-light speed travel, the entire Milky Way and perhaps even beyond would become accessible within a human lifetime, albeit a relativistically stretched one. This would fundamentally alter our understanding of life in the universe, potentially leading to encounters with extraterrestrial civilizations or the discovery of new forms of life and planetary systems. The potential for scientific discovery would be limitless, expanding our knowledge of cosmology, astrophysics, and biology in ways we can barely imagine.